Okay, in this video, we're doing Calc AB problem set 66. The problems and a playlist are in the description below, and let's take a look. All right, we're going to use the graph of f of x shown above to evaluate each of the following. These are definite integrals. So those are the signed areas bounded by the curve in the x-axis. So if you're above, it's a positive area. If you're below, it's a negative area. Let's see if we can do it. So we want to go from -2 to 4. So I like to divide up the region into like convenient things. Here I say from -2 to 0 is, you could call it a trapezoid, or it's a rectangle with an area of 2 plus a triangle with an area of 3. And then from 0 to 2, it's half of a rectangle that's 2 by 4, or it's a triangle with a base of 2 and a height of 4. And then from 2 to 4, we're below the axis, so we're going to get negative area. I look at that and I see a rectangle that's 1 by 4, so that'll give us -4. And then half of a rectangle that is 1 by 4, so that'll give us -2. So now we want to just like add those up. So 5 and 4 is 9, and then -6, which gives us just 3. And that's kind of how you do all these problems. So if I want to go from -6 to +4, I just need to kind of like add in the additional area that I would say I'm going to like divide it into those two regions. That's a 2 by 3, which is 6, and then a rectangle with an area of 2 plus a triangle with an area of 2, so that's another 4. So in this case, we're going to do our new 10 plus our old 9, and then -6. So 19 minus 6, 13. And that's what you do. Like, you do a lot of counting boxes. You divide it up into whatever you're comfortable with. So keep in mind, because we're going to need it at some point in the next problem, that from -6 to +2, -6 to +2 is going to give us 10 plus 9, so 19. So we're getting 19 from -6 to +2. I'm just going to like import that when I need it. So let's look. We want to go from, so this is a weird problem because it says to go from 6 to 2, but 6 is bigger than 2. So what we're going to do is we're going to flip the bounds and change the sign. So we're going to go the negative and then from 2 to 6. You should always do that. The lower bound should always be smaller than the upper bound. So that's like step 1 on any of these. So now I need to know what's happening from 2 to 6. 2 to 6, I'm going to divide up into these three regions. So that's a -2 for that first triangle, a -8 for that rectangle, and then we got 2 and 1, so -3 for this trapezoid. So I want the opposite of the sum of those numbers. The sum of those numbers is 13, or -13. So I want the opposite of -13, which gives me 13. Pretty good. Now for the next problem, we want the integral from -6 to 6 of the absolute value of f of x. So the absolute value of f of x is the graph of f of x anywhere f of x is positive. So from -6 to 2, f of x is already positive. And then the opposite of f of x anywhere f of x is negative. So from 2 to 6, f of x is in the negatives. It's below the axis. So we're going to reflect it over. So you can actually draw it. So I've reflected. And now what I need to do is find both of those areas. Well, we said from -6 to 2 is 19. We were just going to import that. And then we already figured out this other area, like when it was the original was -13. Reflect it, you get +13. So we have 19 for this part. We have 13 for this part. So we have to add those together, and I'm pretty sure we get 32. All right, let's take a look at another problem. We want to evaluate the derivative of the natural log of e to the 5x squared. All right, so you can dive right into this and do like 1 over u times the derivative of u. Not a bad idea, but what I would prefer to do is use a property of logs. So the property of logs that I'm going to use is that exponents inside logs become coefficients of the log. So I'm going to basically, I always say that I'm bringing the 5x squared down. I don't know, but it's really just exponents become coefficients. I say that all the time. So it's going to look like this. We're really finding the derivative of 5x squared times the natural log of e. But the natural log of e is 1. That's a fact that you should definitely, keep in mind all the time, review it every once in a while. Natural log of e is 1, and then the natural log of 1 is 0. It's not coming up here, but you should also know that. So we're really finding the derivative of 5x squared, which is definitely just 10x, and we get our answer. All right, let's take a look at one more. Integral from 0 to 2, square root of x squared minus 4x plus 2 dx. So I look at this, and like my first thought kind of is, unless I can do something algebraic, I'm not really sure how I'm going to do this. But I do think there's something algebraic I can do. So in calculus in particular, when you see a quadratic, you should kind of think to yourself, does that factor? So in this case, I think it does factor. If it doesn't factor, you should say to yourself, can I complete the square on this thing? But in this case, I think we factor. And so I think we can factor that and get the integral from 0 to 2 of the square root of the quantity x minus 2 squared. The square root of x minus 2 squared is the absolute value of x minus 2. So now we've kind of algebraically reduced this problem down to something that we can definitely handle by looking at a graph. So I'm going to do that. So 0 and 2 are important because they're the bounds. 2 would be important anyway because it's the vertex of the absolute value graph. So I'm going to plug in 0, the absolute to get the absolute value of negative 2, which is 2. So that'll be 0, 2. And then at 2, you're definitely just getting 2 comma 0. So this is a triangle. And it's a triangle that has a base of 2 and a height of 2. So it's half of a square that has an area of 4. So our answer here will be 2, which means our definite integral is 2. And that's the entire problem set. I hope you found this helpful, and good luck.